All right, let's look at some other examples of rational function graphing. Here, starting out with this example, you'll notice that we do not have a true rational function. We have two terms here. So we have to adjust this. And to do that, we are going to multiply this x, top and bottom, by x minus 1, this existing denominator. So there's my two terms. We distribute the x. Gives me x squared minus x, and then we'll subtract the 6. And now this is my true rational function right here in polynomial form. So now we'll take care of the horizontal asymptote. Notice here that the top power 2 is bigger than the bottom power 1. So this is an oblique asymptote. Now the good thing here is that we can go ahead and do synthetic division because this is a x to the first power. It's linear. We can do synthetic division. So 1, -1, -6. There's the top row based off of those top terms coefficients. X minus 1 is equal to 0. I solved it for x. X equals 1. And we run it through the synthetic division table. Bring down the 1. 1 times 1 is 1. Minus 1 is 0. And do not find the remainder. It is not necessary. Remember in the definition we said your slant asymptote or oblique asymptote equation has no remainder to it. So do not bother with the last column. So in fact, if you do synthetic division, just scratch everything out. So that's my constant 0. That's my 1x. This is the equation of my horizontal asymptote. Y-intercept, we have constant ratio, -6 over -1. So that gives me 0 over 6. Factor the top to find our x concepts. So 2 factors of 6, that subtract to be -1. How about a -3 and a +2? So x minus 3x plus 2 all over x minus 1. The x minus 1 is in the denominator. Let's make that our vertical asymptote. And then here up in the numerator, we'll have x minus 3 equals 0, which gives me a 3. X equals 3, and an x equals a -2. So there's my x-intercepts. So we're ready to graph this. So again, graphing order, x is first. Everything we got here in blue has to be done first. So let's see, numerical order, -2, then the 1, then the 3. So -2, closed circle because it's an x-intercept. 1, vertical asymptote, open circle. 3, x-intercept, closed circle. Again, looking at your polynomial form, we have x squared over x. That's a positive x squared over a positive x. Right-hand behavior will be positive. And as I go to the left, from 3 down to 1, this will be a negative region. From 1 to -2, that will be a positive region. And everything to the left of -2 will be negative. So I put in my vertical asymptote. And now we can put in all the y concepts. So I put in my y-axis. That's just to the left of 1. And now we're going to plot our y-intercept of 0, 6, way up here, and our oblique asymptote OA, that was y equals x. It had a y-intercept of 0, that's what the 0 is for. And then we're going up 1, right 1, up 1, right 1. It has a slope of 1. And so there is my slant asymptote. So now with all my bits and pieces plotted, we can make the graph. So again, as I mentioned, I like to start over here on the right with my right-hand behavior that I have, my x-intercept. So again, from 3 to 1, for my x's, I have to have -y. So we're going down next to that vertical asymptote right there. And then 3 to the right, to infinity, it's going to come up, and then it's going to run right next to that line, right, that slant asymptote. And then again, if you're down on the right side of the vertical asymptote, you're up here. So we're going up on the left side of that vertical asymptote. We come down, we hit that y-intercept, we hit that x-intercept, and we run right next to that slant asymptote. And there's our graph. Okay, next example. We are in polynomial form, so let's take care of the y's. X squared over x squared, same powers, horizontal asymptote, y equals 1. That's case number 2. Y-intercept, negative 9 over negative 6. Let's see, that's positive 9, 6. That would be a positive 3 halves. So 0, 3 halves. Now we have to factor. Difference of perfect squares on the top. That's going to give me x plus 3, x minus 3. And 2 factors of 6. That's subtract to be a positive 1. X minus 2, x plus... Oh, wait, notice we have 2x plus 3's. So in this case, we're going to have a hole. And we'll come back and take care of that in just a second. So the x plus 3's cancel out. So this is my new rational function. So my vertical asymptote is x equals 2. Not x equals 2 and x equals negative 3. We cancel those binomials out. My x-intercept, set this equal to 0 and solve for x. X is equal to 3. We're at 3, 0. Not 3, 0 and negative 3, 0. You can't have an x-intercept of negative 3, 0 on a vertical asymptote line of x equals negative 3. That's just not going to happen. All right, so to find the hole, we take that x plus 3, set it equal to 0, the one we canceled out. That's x equals a negative 3. Substitute that into our new fraction here. Negative 3 minus 3 is going to be a negative 6. Negative 3 minus 2 will be a negative 5. Negative over a negative changes to a positive, so we're right here at 6/5. Negative 3, 6/5, or 1.2 if you want to have a decimal. So this is going to be an open circle that I'm going to plot when I plot the y concepts. So we go to our graphing. We're going to do all the x's first. So we have a 2 for a vertical asymptote and a 3 for an x-intercept. Really close right here. Open circle with the 2, closed circle with the 3. Oh, I don't know why I have my y-axis in here. It shouldn't be here right now. Well, I'll tell you why I don't put it in here with this example then. So right-hand behavior is going to be positive because we had a positive x squared over a positive x squared. That's positive, negative, and it's positive everywhere else here. Now this is one of the reasons why I don't want you to graph your y-axis until you put in your y concepts. A lot of people will do this. Positive, negative, and then they'll put a positive between the 2 and the y-axis, and then negative after the y-axis. There's no x's over here, so there's no sign change. So it's a good reason to put off putting your y-axis until you're ready to plot your y's. So put in our vertical asymptote. I'm going to put in my 0, 3 halves for my y-intercept. My y equals 1. Here's my horizontal asymptote. And you can see everything to the left of 2. There's my positive y-intercept, so that's a good sign. And that's where we should be at. Now, the other thing we have to put in is our hole. So the hole happened over here at negative 3. And 6/5 is slightly bigger than 1, like about 1.2. So I have to be just above that horizontal asymptote right here. There is the hole. So now to start graphing our rational function, we can start over here on the right, again, from 3 to the vertical asymptote going down to just underneath the horizontal asymptote. And then if I'm down on the right, I'm up on the left, where I come down from this vertical asymptote on the left side of it. I hit the y-intercept, I approach the hole, touch it, jump over it, and continue onward. And there's my graph.